Welcome, curious minds, to another adventure on Mathlete Minds. Today we'll be unraveling some more mysteries pertaining to quadratic polynomials. Now, the first one over here is finding the quadratic polynomial when the sum and product of its zeros are given. That means we have to determine a quadratic polynomials where the sum of the zeros is 5 and the product of the zeros is 6. Now, the general representation of a quadratic polynomial fx is given as ax squared plus bx plus c is equal to, in terms of its zeros, we can write the expression as k into x squared minus alpha plus beta into x plus alpha beta, where alpha and beta are the zeros. Apart from that, alpha plus beta is equal to minus b upon a, and alpha beta is equal to c upon a. So getting back to this expansion over here, to write the new expansion, what we do is take this expression in terms of the zeros, and we get the new polynomial fx is equal to k into x square will be written as it is, and sum of the zeros is 5. So put 5 over here, minus 5x, product of the zeros is 6, just put 6 over here. But writing k is mandatory because k can assume any value. It is a constant, it can be integer, it can be a fraction, whatever it is. You will find that the sum of the zeros is 5 and the product of the zeros is 6. And so we can get n number of quadratic polynomials with sum of the zeros is 5 and product of the zeros are 6. So there is no restriction to the number of polynomials that we can derive, and that is why writing k is mandatory over here. So this, supposing, let's take an example. If I take k as equal to 3, then this expression becomes, or the new polynomial that we can generate is 3x squared minus 15x plus 16 plus 18. Now, here we have a as 3, b as minus 15 and c as 18. So, alpha plus beta, which is equal to minus b upon a, that becomes equal to minus into minus 15 upon 3, that is equal to 5. And alpha into beta, that is equal to c upon a, that is 18 upon 3, that is equal to 6. So, we get the sum of the zeros as 5 and the product of the zeros as 6. You can take any value of k and check for yourself. You will always arrive at this final result, that the sum of the zeros is 5 and product of the zeros is 6, for the simple reason that this k value, it always gets cancelled over here, and in any context you will find that the k values will be cancelled and you will get the sum of the zeros is 5 and product of the zeros are 6. Next is finding an unknown value in the polynomial when the sum or product of the zeros is given. Either the sum is given or the product of the zeros is given, either of them, and you need to find one unknown value. Now, in this particular question, we are not given the value of a, but the value of b, that is minus 6, and the value of c is minus 6. So, we need to find the value of a, that is the coefficient of x squared. Now, if we take the product rule away, alpha into beta, that is equal to c upon a, because here it's given that the product is 4. So, we'll take the product rule, alpha into beta is c by a. Now, getting back to this relation, if I just substitute the values, I'll get here 4 is equal to c is minus 6 and a is a over here. So, we get a is equal to minus 6 upon 4, that is equal to minus 3 upon 2. So, the value of this constant, this coefficient of x square is minus 3 upon 2. Next concept is, if one zero of the polynomial is the reciprocal of the other, then find the value of a. So, here you can see a is present in the coefficient of x square and a is also present in the constant term, and we need to find that value. And it's given that the one zero is the reciprocal of the other. Now, if the two zeros are alpha and beta, we can either take beta is equal to 1 by alpha, or we can take alpha is equal to 1 by beta. Either of them, it's your choice. So here, getting back to the expression, now here we'll take the product rule, alpha into 1 by alpha, that is equal to c by a. C over here is 6a and a is a squared plus 9, the entire expression inside the bracket. Now, why we take the product rule, that will be clear just now. So, alpha into 1 by alpha becomes 1. So, this is 6a by a square plus 9. And if you cross multiply this, you get a square plus 9 is equal to 6a, which can be written as a square minus 6a plus 9 is equal to 0, which becomes equal to a squared, or if we take it as, instead of factorizing it, we can straight away write it as a minus 3, the whole square. It's a perfect square. So we get both values of a as 3. Even if you factorize it, you will get the same values of a. Next concept is, if one zero of the polynomial is the negative of the other, then find the value of k. So here 1 0 is the negative of the other. If the zeros are alpha and beta, we can either take alpha is equal to minus beta, or we can take beta is equal to minus alpha. So I am taking here beta is equal to minus alpha. Now here we'll apply the summation rule, alpha plus beta is equal to minus b upon a. So this will also be clear just now, because here you will notice that if I take the summation rule, I'll get here alpha plus minus alpha is equal to minus b, that is minus into minus 8k divided by 4. So this left hand side becomes 0, and on the right hand side you get 8k by 4. So automatically this says that k is equal to 0. Whether you divide this and make it 2k and simplify, you still get 0, or whether you cross multiply and divide by it, still you get 0. So here we took the summation rule. So you need to identify whether you have to take the summation rule or the product rule. Next one is finding the values of a symmetric expression involving zeros of a quadratic polynomial. Now here we are given the general polynomial ax square plus bx plus c, and we need to find the squares of the sum of the squares of the zeros in the first case, and here we are given another expression alpha by beta plus beta by alpha. So we'll take one at a time. Now from this ax square plus bx plus c, we can write the sum of the zeros as minus b upon a and the product of the zeros as c upon a. So now alpha square plus beta square can be written as alpha plus beta the whole square minus 2 alpha beta. Whenever you get any expression, you need to first put it in this format, the sum of the zeros and product of the zeros. Then only will be able to substitute these values over here. So this becomes, and this is equal to this. Why? Because if you expand this using a plus b whole square, you will get here alpha square plus 2 alpha beta plus beta square minus 2 alpha beta. So plus 2 alpha beta and minus 2 alpha beta will be cancelled, and you will be left with alpha square plus beta square. So this is equal to, if we put the values here, this becomes minus b upon a the whole square minus 2c upon a. So if we simplify this, we get here b square upon a square minus 2c upon a. And on further simplification, that is by taking the LCM, we'll get it b square minus 2ac upon a square. So this is the value of alpha square plus beta square in terms of the coefficients and constants. Now getting back to the next expression, that is alpha by beta plus beta by alpha. Again, first we need to put it in the format of alpha square plus beta, alpha plus beta whole square and alpha beta. So if I take the LCM over here, this becomes alpha square plus beta square by alpha beta. Now again, alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta by alpha beta. So this becomes equal to alpha plus beta whole square is minus b by a the whole square minus 2c upon a divided by c upon a. So this becomes equal to b square upon a square minus 2c upon a divided by c upon a. So that makes it into a upon c. So if you take the LCM, you get here b square minus 2ac by a square into a by c. So ultimately this is equal to b square minus 2ac by ac. This a and this a square, one of the a's will get cancelled over here. So we are getting this final outcome in terms of a, b and c for the expression alpha by beta plus beta by alpha. Next is, if alpha and beta are the zeros of the quadratic polynomial fx is equal to kx square plus 4x plus 4, such that alpha square plus beta square is 24, then find the value of k. So here the sum of the squares of the zeros is given. Then find the value of k. So getting back to alpha plus beta, is equal to minus b upon a and alpha beta is equal to c upon a. So as in the previous case, what we are supposed to do is write down alpha square plus beta square as the sum of the zeros and product of the zero. So this can be written as alpha plus beta whole square minus 2 alpha beta. Now from here, A is k, B is 4 and C is 4. So now alpha plus beta whole square, this will become equal to this, for this particular polynomial, I can write this as minus 4 upon k, and here I can write as 4 upon k. So substituting the values here, we'll get here minus 4 upon k, the whole square, minus 2 into 4 upon k. And the question says alpha square plus beta square is 24. So here on the left hand side, we'll get 24. So this becomes 24 is equal to 16 by k square minus 8 by k. So on taking the LCM, you get 24k square is equal to 16 minus 8k. Or this becomes 24k square plus 8k minus 16 is equal to 0. Taking out 8 common, we get over here 3k square plus k minus 2 is equal to, taking out 8 common, we get here 3k square plus k minus 2 is equal to 0. So this becomes equal to 3k, taking the this expression as doing middle term splitting, we get over here 3k and this k square, and this can be written as 3k minus 2k minus 2 is equal to 0. So taking out 3k common from the first two terms, we get k plus 1, and 2 common from the last two terms, we get k plus 1 is equal to 0. Again taking out k plus 1 common, we are left with 3k minus 2 is equal to 0. So k is equal to minus 1 or 2 by 3. Both the values of k will justify this expression. Next is determine a quadratic polynomial by using the values of sum and product of the zeros of some other quadratic polynomial. So here we are given one particular quadratic polynomial, and on the basis of the sum and zeros of this quadratic polynomial, we need to generate another quadratic polynomial with the help of the zeros of this one. So here if I take this polynomial, you find over here in this polynomial alpha plus beta, which is minus b upon a. That will be minus 0 upon 1, that is 0. Because here you find the b term is missing, so b is obviously 0. A cannot be 0, otherwise the quadratic polynomial will cease to exist. So it becomes a linear polynomial. So here it becomes minus 0 by 1, so this is 0. And alpha into beta, that is c by a, that makes it minus 1 upon 1, that is minus 1. So for this polynomial, we get the sum of the 0 as 0 and product of the 0 is minus 1. Now getting back to this new polynomial that we need to generate, whose zeros are 2 alpha by beta and 2 beta by alpha. So first of all, we'll find the sum of the zeros. So sum of the zeros in this case will be equal to 2 alpha by beta plus 2 beta by alpha. Now, if you take the LCM, this becomes 2 into alpha square plus beta square by alpha beta. So, this becomes equal to 2 into alpha plus beta the whole square minus 2 alpha beta upon alpha beta. Now, putting the values of alpha plus beta whole square from here, this becomes equal to 2 into 0 square, that is 0, minus 2 into minus 1 divided by minus 1. So this becomes equal to 2 into, this becomes plus 2 into 2, that makes it, we can straight away write over here 4 by minus 1, that is minus 4. Then let us find out the product of the zeros. So product of the zeros will be what? Alpha into beta for the new polynomial. The product will be equal to, we can take the help of the original polynomial, that is minus 1. And for the new polynomial, 2 alpha by beta into 2 beta by alpha, here you find that all alpha betas are cancelled out and we are left with 4. So the product of the zeros in the new polynomial is 4. And the sum of the zeros was coming as minus 4. So to frame the polynomial, we get back to this expression that we have learnt earlier, x square minus sum of the zeros minus the sum into x plus product of the zeros. So we take this expression and just substitute the values. So we get here k x square minus the sum of the zeros is minus 4. So minus 4 into x plus the product of the zeros, that is 4. So this becomes equal to k into x square plus 4x plus 4. So this is your final this polynomial, quadratic polynomial, in terms of zeros of another polynomial, that is x squared minus 1. The zeros of this polynomial were defined by 2 alpha by beta and 2 beta by alpha. So that is how you get the solution. Now, anytime you get the solution, first you need to find a question. First you need to find the values of alpha plus beta and alpha beta from the first polynomial, and then get the values of this new polynomial that you have to generate. Find the sum of these two zeros and find the product of these two zeros, and ultimately get back to this expression and put the values here. So that was all in this video for now. Hope you like the explanation. Kindly like and subscribe to my channel. Thank you for watching.